chemical equilibrium. In our previous video, we have learned that chemical equilibrium is how far is the reaction. How far is the reaction? Okay? Now, we have here a question. We are going to use what we have learned about the Le Chatelier principle to answer the questions that we have here. Now, we have PCl3 plus Cl2 giving PCl5. And this arrow, the two arrows, one going to the left, another going to the right. And the reaction is exothermic reaction. Exothermic, when the heat, the difference of heat is less than 0, that means it is exothermic. But if it is negative, okay, it is a negative value. So we say here that it is exothermic reaction. Now, they say predict the effect on the position of equilibrium of adding more chloride. Adding more chloride. So, remember, the Chatelier principle says that if a stress is applied to a system at equilibrium, the system will readjust to relieve the effect of the stress that is applied. Now, we add in the system, we add more chloride. What is going to happen? The reaction or the equilibrium will shift to the right, producing more PCl5. So because we need to consume, the chlorine added need to be consumed. Okay, the chloride added need to be consumed. So more PCl5 will be produced. And the equilibrium shift to the right. Okay, so adding more chloride in the system here, the equilibrium will shift to the right, producing more PCl5. Now, increase the volume of the container. Increase the volume of the container, that means to decrease the pressure. To decrease the pressure here. Now, we have a gaseous reaction. We have two molecules or 2 moles at the left-hand side and 1 mole at the right-hand side. So 2 moles, 1 of chloride, 1 of PCl3. So in total, we have 2 moles here. At the right-hand side, we have only 1 mole. Now, we have learned that in this gaseous reaction, if we increase the pressure, the equilibrium will shift toward the direction where we have less number of molecules. That means if we increase the pressure here, the equilibrium will shift to the right. Okay? If to increase the pressure, that means go to reduce the volume of the container. If we reduce the volume of the container, we are going to have the equilibrium shift to the right, producing more PCl. Now, in our case, the volume of the container is increased. Volume is increased. That means we reduce the pressure. If we reduce the pressure, the equilibrium will shift to the left, and producing more of this product and more of that product. So I repeat that here, when they say they increase the volume of the container, to increase the volume of the container, that means they decrease the pressure. But we have learned that the Chatelier principle predicts that if we increase the pressure, that means if we reduce the container, the volume of the container, we are going to have more of this. Why? Because over at the left-hand side, we have 2 moles, 1 mole of that, 1 mole of that, and in total 2 moles. But at the right-hand side, we have only 1 mole. So this, the effect of increasing the pressure, the equilibrium will shift to the right. But when we decrease the volume of the container, that means, when we increase the volume of the container, I repeat, when we increase the volume of the container, that means we decrease the pressure, we are going to have more of the product. The equilibrium will shift to the left-hand side, producing more of this product and that. So now increase the pressure. Now if we increase the pressure, that means we reduce the volume of the container, we are going to have more of this product, because at the left-hand side we have 1 mole, at the right-hand side we have 1 mole, but at the left-hand side we have 2 moles. 1 plus 1 make 2, but here is only 1. So if we increase the pressure, we are going to have the equilibrium shifted to the right. Now, adding a catalyst. Adding a catalyst has no effect on the equilibrium. Adding a catalyst will have no effect on the equilibrium. But his advantage is that you are going to work in low temperature. You don't need to supply heat to reach the equilibrium. Okay, you don't need to supply heat. So this is the only advantage. But equilibrium, the position of equilibrium will not be affected by the addition of catalyst. Okay? Now, increasing temperature. Now, we have said that the forward reaction is exothermic. Exothermic. When you go to the right, it is exothermic. Now, when you supply heat, stress is applied. Now, the system will readjust to relieve the stress. That means it will go, the equilibrium will shift to the left-hand side. Equilibrium will shift to the left-hand side when we increase the temperature. Okay, because the forward reaction is exothermic and the backward reaction is endothermic. Endothermic. Okay, so I repeat, increasing the temperature, the equilibrium will shift to the left-hand side, producing more of this and more of that. Now, removing some PCl5. Now, what will be the position, the effect on the position of equilibrium when we remove some PCl5? When we remove more, if you remove some PCl5, now the system will readjust to replace what is removed. Okay, so the equilibrium will shift to the right. We shift to the right just to replace the quantity of PCl that has been removed. Okay?